worries at all. Alright, Assalamu alaikum. Today's tutorial is going to focus on data cleaning, data visualizations, and कुछ हम content cover करेंगे for merging and joining, which was recently covered on a theoretical level in class. We have a couple of exercises, but real quick, I do want to show you guys कि आपके पास Kaggle पे ये content कहाँ पे available है. We've probably iterated it before as well. So you have a Kaggle guide available over here that should help you set up. And this is a platform that we highly encourage that you use for your group projects, for collaborative work. Kaggle is far better than Google Colab is. क्योंकि Kaggle पे you can do version controlling. You have lots of space available for data. आप 100 200 GBs के data sets रख सकते हैं. And then you have lots of open source code and data available for your use as well. You can look up ideas for your projects here too. And इसको आप लोग, I would encourage that you guys set this up. It gives you 30 hours of GPU time each week for use as well. There is a details document available over here for your reference. Tutorial 3 के लिए I will add the link to the notebook by the end of tutorial 3. For tutorial 2 and onwards, you have links to your notebooks and your data sets available. जब आप एक notebook में जाएंगे यहाँ से, so this is where you will be able to view the versions of notebooks that we've covered as well. Anyway, on that note, we are going to continue with today's content. This is the notebook that we will be using today, and this is the data set that we're using in your notebook. You guys can ignore the temporary one. I added that for my own use. So we're going to start with data cleaning. I think that this is readable enough already. जब आपने Kaggle पे path copy करनी होती है, तो you have them available right over here. If I click on this, for instance, so I've essentially been able to copy the path to my data set directly. And this is the one that we're using right now, life expectancy data. So anyway, data cleaning is part of the very recent module you've started in class, data cleaning and visualizations. It is the process of detecting and correcting any inaccuracies, inconsistencies, anomalies, errors in your data sets. Because before you can model your data, before you can make inferences from your data, you have to ensure that your data is reliable, the quality of your data is consistent, और आपके डेटा सेट्स में कोई एरर्स नहीं है, डुप्लीकेट वैल्यूज नहीं है, you don't have any missing values in your data set either. So essentially it also involves at some point you'd want to ensure that everything is in a standard format so that your data is accurate and that it is usable for analysis. This is the data set that we're going to work with, life expectancy data. इसके अंदर आपके पास available हैं 2,938 rows and you have 21 columns available. So I have year, status, life expectancy, adult mortality, and so on and so forth. ये WHO का data set है essentially. If I write df dot columns, so I should be able to view all the columns that are available in my data set as well. Anyway, one of the first things that you would want to do as a data scientist would be to check and remove any duplicate entries because you don't want to represent something twice or more than once in your data set. इसकी command बहुत simple है essentially df dot drop duplicates. अब duplicate क्या consider होगा? If there are two rows in which every single value is the same, जैसे there are two rows जिनका year भी same है, status भी same है, life expectancy, adult mortality, essentially the values of all columns are the same, so that would be considered, those would be considered duplicate rows, and ये उनमें से एक row को drop कर देता है. However, drop duplicates के अंदर आप एक argument भी दे सकते हैं, subset equals. और सबसेट में अगर आप एक कॉलम्स की लिस्ट पास करें तो वो सिर्फ उन कॉलम्स की बेसिस पे डुप्लीकेट्स को ड्रॉप करता है जाके। फॉर इंस्टेंस आई हैव ए डेटा सेट जिसमें मेरे पास स्टूडेंट्स के लिए मल्टीपल एंट्रीज हो सकती हैं, बट आई वांट कि एक स्टूडेंट के लिए सिर्फ एक एंट्री एग्जिस्ट करे। सो फॉर इंस्टेंस आई हैव स्टूडेंट grade, GPA, etc., etc. I have whatever characteristics for a student. It is possible कि कोई दो एंट्रीज हो गई हैं जिनमें स्टूडेंट आईडी सेम है लेकिन किसी और वैल्यू का मिसमैच भी है। तो इफ आई स्पेसिफाई df डॉट ड्रॉप डुप्लीकेट सबसेट इक्वल्स स्टूडेंट आईडी, तो वो सिर्फ जहाँ पे स्टूडेंट आईडीज रिपीटेड है उन पूरी रोज को ड्रॉप कर देगा टू इंश्योर दैट ओनली वन इज अवेलेबल। Then you can specify another argument as well, actually. Keep equals first, I guess, or it's keep first equals true. Like in our context, this doesn't really matter. I could specify year over here, in which case ये सिर्फ एक year की एक ही entry इसमें रहने देगा, but I'm not gonna do that because I'll get rid of a lot of my data that way. I don't want to do this on the basis of year, but if I simply do dot drop duplicates, तो I will see कि मेरी number of rows कम नहीं हुई, which essentially means कि इस data set में there were no two rows that were exact copies of each other. All the rows were essentially entirely unique. But to show you how this works, अगर मैं subset में year specify कर दूं, तो फिर आई एम ओनली लेफ्ट विद 16 रोज। इसका मतलब है सिर्फ 16 यूनिक ईयर की एंट्रीज एग्जिस्ट करती थी। सो आई एम गोना गो बैक एंड रिवर्स। मेरा ओरिजिनल डेटा फ्रेम मॉडिफाई नहीं हुआ बिकॉज मैंने रिजल्ट को कहीं पे रिसीव नहीं किया। इसके लिए यू हैव अनदर कमांड, आई विल शो यू अगेन एज वेल। इट्स कॉल्ड इन प्लेस। अगर आप इन प्लेस इक्वल्स ट्रू सेट कर दें तो वो ओरिजिनल डेटा फ्रेम को मॉडिफाई कर देता है। अगर इन प्लेस इक्वल्स फॉल्स आप सेट कर दें एंड इन प्लेस इज इक्वल टू फॉल्स बाय डिफॉल्ट, तो देन ये एक डेटा फ्रेम रिटर्न करता है आफ्टर रनिंग अ कमांड ऑन दिस। सो essentially then you have to do this in order to modify your original data frame. So अभी in place equals false है and well I know कि कोई change बनता नहीं है इसके अंदर if I just drop duplicates, but if I write subset equals here and then I run the exact same thing, तो अब मेरा original data frame modify हो चुका है। Similarly अगर मैं in place को true set कर दूं and then I run this command, तो भी मेरा original data frame modify हो जाएगा। In place is not something that is specific to just drop duplicates. It works for a lot of other pandas के functions as well, which we'll see shortly. So abhi ke liye I'm gonna get rid of this. And I'm gonna, since now I've already modified my data frame, so I will have to go back up and read the data again into my df variable. Alright, so that's how you deal with duplicate values. Next, you will want to handle missing values, and there could be several ways to handle missing values essentially. Why are there missing values in your data set to begin with? या कोई error हो सकता है when you are recording data. Maybe the subject did not have enough knowledge about a certain attribute's value. अगर आपने एक question पूछा है, for instance, it's an open-ended question or so, and maybe there's an option where your responder can choose to leave it blank. Maybe it's not a compulsory question in a survey, even if it's of an objective nature. Then similarly data collect करते हुए शायद कुछ attributes की आपको नहीं knowledge, शायद because of an error you accidentally skipped recording a value. So there are several ways to handle these missing values though, but essentially primarily दो ही तरीके बनते हैं. Then we have extensions of those methods, and then we have subtypes of those methods essentially. I mean, either you can drop a missing value or you can replace that missing value with something. या तो उसको fill कर दें या उसको drop कर दें. And then इसकी हमारे पास काफी extensions हैं which we'll look at. So let's look at how you can drop these, or my bad. First, let's look at how you check for missing values. If you write df dot is null, तो वो आपको ये चीज return करता है. इसकी dimensions are the exact same as your original data frame, 2938 rows times 21 columns. जहां पे फॉल्स लिखा हुआ है वहां पे वैल्यू नल नहीं थी, बिकॉज आपने इज नल पूछा। जहां पे ट्रू लिखा हुआ है, जो मुझे अभी लिखा हुआ तो नहीं नजर आ रहा है यहाँ पे, बट जहां पे ट्रू लिखा हुआ है वहां पे द वैल्यू वाज essentially missing. Let's see what happens if I write dot sum. अब इसने मुझे सम दे दिया मिसिंग वैल्यूज का। सो दिस इज इंटरेस्टिंग। आई कैन सी कि लाइफ एक्सपेक्टेंसी कॉलम में 10 वैल्यूज आर मिसिंग। मतलब अक्रॉस माई 2900 एंड समथिंग जितनी भी रोज थी, 2938 रोज, सिर्फ 10 ऐसी रोज थी जिसमें लाइफ एक्सपेक्टेंसी की वैल्यू मिसिंग थी। बट सिमिलरली देर आर सम वेरिएबल्स जैसे पॉपुलेशन है जिसकी 652 मिसिंग वैल्यूज एग्जिस्ट करती हैं। So this is how you check for is null. Oh, so this command is already here as well. Then what you could do is you could drop rows that contain missing values. अभी मैंने सिर्फ एक कमांड लिखी है df डॉट ड्रॉप na. अब you guys will see कि ये चीज बार बार आती है actually. In place you can fit into most pandas functions. This is an option for most pandas functions. So if I write in place equals false, now I know that that doesn't modify my original data frame. That returns a data frame with an update. And this is what I'm doing right now, because अगर मैं अपने original data frame को modify कर दूं while showing you one technique, तो मुझे अगली technique दिखाते हुए data frame को दोबारा I would have to read my CSV again into my data frame. So this is how this works to show you the output. तो अब मेरी rows essentially काफी कम हो गई हैं. Previously, I had 2,938 rows and now I have 1,649 rows across my same 21 columns. So essentially हुआ क्या? एक row के अंदर 21 features and 21 columns हैं. Since उन 21 में से अगर कोई एक भी कॉलम की वैल्यू मिसिंग होती है तो ये कमांड उस पूरे रो को ड्रॉप कर देती है. बट देन द क्वेश्चन इज दैट द बेस्ट वे टू गो अबाउट थिंग्स? Essentially, it isn't. Kyuki, well, data is expensive, data is hard to collect, and data is very valuable. So you don't want to randomly just get rid of your data. You have to save your data wherever you can. If you randomly get rid of your data, and you'll see this towards the end of the course as well, so sometimes you could introduce a bias. Sometimes you are just, well, getting rid of an essential demographic, as an essential category जो आपको नहीं खत्म करनी चाहिए थी in your data set. So instead of just randomly dropping things, we find ways to handle these things as well. With that being said, maybe it makes sense कि अगर 21 values में से मेरे पास 19 values missing है, तो फिर उस रो का क्या करना है मैंने? मे बी दैट इज नॉट मीनिंगफुल फॉर मी एनी लॉन्गर. देन इट वुड मेक सेंस टू ड्रॉप दैट रो. अगर मेरे पास 15 to 20 वैल्यूज मिसिंग है आउट ऑफ 21 एक सिंगल रो में, तो मे बी आई कैन ड्रॉप दैट रो. दैट्स अ वेरी सेन डिसीजन एक्चुअली. लेकिन अगर 21 में से सिर्फ एक वैल्यू मिसिंग है, तो मे बी आई शुड save that row. I shouldn't drop that row. I should just fill that single missing value with something. So this is how you will go about it actually. बहुत simple technique है. अच्छा, ये by the way just to show you कि command run करने के बाद मैंने इस नए data frame में अपना result store किया था df with dropped rows. जब मैं इस पे dot is null dot sum करती हूँ तो ये 0 0 0 हो गया because सारी missing values वाली rows तो drop हो गई थी. Anyway, what you can do is that you can add a certain threshold. It's a variable named thresh. If I've written thresh equals 18, 21 मेरे पास columns थे essentially. अगर मैंने 18 लिख दिया तो it means कि in order to drop a row, more than 18 values out of 21 must be missing. So essentially अगर कोई भी ऐसी row है जिसमें 2 या 2 से कम नॉन नल वैल्यूज हैं तो it's going to drop that row, and I think that that should make a lot of sense as well. I can modify my threshold as well, but let's see what the result is right now. I have 2,730 rows. I've preserved a lot of my data this way. Initially 2,938 rows थी. So I know कि जो 1,208 rows drop हुई हैं, उन rows में literally like at least 19 of your columns were blank. But that makes a lot of sense. I mean, अगर 19 columns blank थे और मैंने drop कर दी तो that's perfectly fine. You can play around with this threshold actually. Maybe I can set it to 20. And अब सिर्फ वो वाली rows drop होंगी. See, this number has increased because अब और भी कम rows drop हुई हैं. Only those rows were dropped where one value was missing. So that's how threshold works. Similarly, you can drop columns with missing values as well, and this is going to be slightly daunting at first, but and the reason being कि जब आप लोग dot apply learn कर रहे थे and you looked at dot apply in your previous tutorial as well, तो by default columns were selected. अगर आपने rows select करनी होती थी तो आप axis equals 1 specify करते थे. By default the axis is always 0. जब आप axis equals 1 specify करते थे तो वो rows के ऊपर run करता था. अब यहाँ पे it's actually the opposite. If you want to drop columns instead of rows, so you write axis equals 1, which essentially means that axis equals 0 was already representing your rows. So that's an important distinction. We're probably not going to test you for this distinction, but just for your information. So exact same command df dot drop na, बस मैंने axis equals 1 specify कर दिया. And let's see, initially I had 21 columns और अब मेरे पास सिर्फ 7 columns बचे हैं. Note that the number of rows remains unchanged. So I'll tell you what, एक column के साथ 2,938 values हैं एक column के अंदर. हमने कहा कि अगर उन 2,938 वैल्यूज में से कोई एक भी मिसिंग होती है तो just drop the entire column. We don't need the column. Which is again not the wisest way moving forward, because if I take you back up, you'll see that there are some columns जिसमें सिर्फ 10 values missing हैं literally, and out of 2,900, that's not a very big number. So you shouldn't drop those entire columns. So what is the solution? Once again, जिस तरह हमने rows में देखा था, this is to again show you कि जो columns बचे हैं उनमें non-null count, sorry, null count is actually 0. So उसका solution ये है कि आप इसमें भी threshold को specify कर सकते हैं. But you will specify it here as a proportion. So if I write 0.9, it means drop the columns where more than 90% of the values are missing. Don't drop the rest. And now I've preserved all my columns. Let's try and modify this. 50% अगर इसको हम कर दें. So I've still been able to reserve all of my columns. If I make this 20%, I still have all my columns, and you would remember कि जो highest number of missing values थी एक column में वो 600 and something थी. So if I make it 10%, well, I still have all of them. I could make it 5%. इसको आप खुद decrease करके देख लें beyond this. Anyway, moving forward, then you have methods of filling missing values. Abhi, we've just looked at techniques for dropping rows or columns that contain missing values. So you've looked at techniques for dropping missing values. Now, there are some cases in which you would want to fill missing values as well. And I would like to add over here actually कि जो आपका data cleaning का process है, there's no one hard single way of going about things. You'll do a combination. जैसे जब आप अपने projects के data sets के साथ काम करेंगे, for instance, so maybe you could do something like you can begin with dropping all the rows जहाँ पे maybe like more than 90% of the column values are blank, which makes sense. Then maybe you could drop the columns where more than 80-90% of the data is missing. That would be fine. उसके बाद जो remaining missing values हैं, you would want to fill them with something instead of just dropping those rows or columns. So it's always a combination of the two. Anyway, अब missing values को fill करने के कई तरीके हैं. The simplest one being कि you just replace it with some arbitrary number, with some arbitrary value, किसी भी random number के साथ आप replace कर रहे हैं to indicate कि यहाँ पे value essentially missing थी. Maybe it's not the best way moving forward because that arbitrary number is, well, obviously it's not meaningful to you. So anyway, beyond that, you could do a forward fill or a backward fill. This is the next simplest technique. ये बहुत आसान है. अगर आप forward fill कर रहे हैं तो essentially जो उसके बिल्कुल आगे नेक्स्ट नॉन नल वैल्यू अवेलेबल है वो उससे रिप्लेस कर देगा उस वैल्यू को. सो अगर एक कॉलम में आप जा रहे हैं एंड द वैल्यूज लुक लाइक 2 3 4, नेक्स्ट वैल्यू मिसिंग, उससे नेक्स्ट वैल्यू 10, तो जो 10 उसे नेक्स्ट नॉन नल वैल्यू मिली है वो उसको लिख देगा वहां पे जहाँ पे वैल्यू मिसिंग थी. बैकवर्ड फिल इज द एग्जैक्ट ऑपोजिट. इट विल टेक द लास्ट अवेलेबल वैल्यू एंड रिप्लेस इट with your missing value. So these are simple filling techniques. Then you have mean, median, or mode imputation. This is very simple. Mean imputation means कि उस कॉलम में जो मतलब नॉन नल वैल्यूज हैं उनका मीन लेके उस मीन को फिल इन कर दें हर नल वैल्यू की जगह पे. Median में you are replacing every null value with the median of non-null values in your column. Mode may you use the mode instead of the mean or the median. So that's very evident. Similarly, then you have, well, you have interpolation, which is a better technique, actually, a more complex, more precise technique moving forward. Interpolation involves estimating the missing values by using the values of your neighboring data points. Then you have different kinds of imputation available as well, just a linear interpolation, a quadratic interpolation, and so on and so forth. इनकी complexities ना lecture में covered हैं और ना हम tutorial में cover करेंगे, but you're welcome to explore this further when working on your project. As of now, these are the techniques that are available to you. Essentially, interpolation को आप तब use करते हैं when you know that your missing values are missing essentially completely at random और data का trend आपका काफी smooth है, which means कि उसकी neighboring values को use करके you can have a good estimate of what the missing value should look like. Are there any questions up until now? All right, so moving forward, let's see. Suppose I want to replace with mean. हम एक दफा दोबारा देख लेते हैं. df dot is null dot sum, and then I am taking my GDP column right now. GDP column के अंदर 448 values are missing. जब मैं डॉट मीन रन करूंगी तो वो मुझे उन values का मीन देगा जो missing नहीं है, obviously. And maybe mean is a good enough metric for me to use as a replacement for all missing values in my data set. So this is what I do. जिस तरह आपके पास कमांड है is null की, drop na की, उसी तरह आपके पास fill na की कमांड है, just like drop na. Fill na means that fill a given column with a certain value wherever null values exist. You call it on a series, so df gdp dot fill na. fill na के अंदर आप वो वैल्यू पास करते हैं जिससे आपने fill करना है. मैंने ये वैल्यू पास किया. I could have stored it somewhere and passed it as well. Like इसको एक वेरिएबल में स्टोर कर लेते हैं. For instance, mean gdp equals, and then I could just do this. Mean gdp, and I've set in place to false. तो इसको हम कहीं पे रिसीव करके देख लेते हैं. न्यू df equals, oh, so what I've essentially done is कि मैंने सिर्फ GDP को restore कर लिया है. I should have done that for my entire data frame. Or I should have just done in place equals true in this case. सो इसेंशियली जहाँ आपने मीन जीडीपी की वैल्यू स्पेसिफाई की है और उसने इस नंबर से रिप्लेस कर दिया हर मिसिंग वैल्यू को, you could have specified an arbitrary number like that as well, and that would have worked in the exact same fashion. You could have written dot min dot max. However, filling in a missing value with the minimum or the maximum value available in a data set doesn't make a lot of sense, because that number is not well representative of what the other values in your data set for that column look like. मैंने इसको सही डेटा फ्रेम पे रन नहीं किया, so I'm gonna do this. And then when I do this, so I will see कि GDP में there are zero missing values now, since उनकी missing values को मैंने replace कर लिया. So forward fill, backward fill के लिए you have the exact same command fill NA, बस एक इसमें parameter है method जिसको आप इस तरह replace कर देते हैं. F fill means forward fill. Similarly, so this runs on all columns by default, वरना आप column specify भी कर सकते हैं. Similarly, if you write B fill, that would mean backward fill. This is what your interpolation command looks like. Not fill NA, but df dot interpolate. Then you specify the method. You're welcome to research further methods available and how this works, but details of these techniques are out of the scope of your course. This we're not going to cover right now because you haven't covered regular expressions in class yet. But I will show you a new data set though. This is your data set, economy of US. इसमें ये वाले columns आपके पास available हैं. इसको हम थोड़ा सा simplify कर लेते हैं. Like that. So I'll tell you what you're doing over here. Then let's remove RE as well. Write a function that cleans the inflation change column of your data set. I would encourage you to revisit this once you're done with REs as well. Maybe I'll reiterate it in your next tutorial. So the function should replace all missing values with unknown. अब आप देखिए ये NaN से नजर आ रहा है मुझे कि ये टॉप पे ही एक missing value पड़ी हुई है. So you will replace all missing values with this arbitrary value, which is called unknown. Then you will convert all the cleaned values to lowercase. I can see कि यहाँ पे कई values में initial your letter is in uppercase essentially. Apply हम use करेंगे dot apply. So यहाँ पे तो dot apply call किया हुआ है for that function on that series, and you're receiving it in the same column as well. This is how you will fill in that function. You have जिस तरह PD के data frame में you have is null available, उसी तरह you have PD dot is NA. Is NA को एक value pass करें तो वो बस बता रहा है whether that value is null or not. So all I did was if PD dot is NA return unknown, and then I will what I will do is कि मैंने इसके बाद return करना है your text dot lower, which will convert it to lowercase. Now if you look at that, तो ये सारे lowercase में हैं और जहाँ पे value missing थी वहाँ unknown लिखा हुआ है. With that, that will be all for data cleaning. We are going to, from an exam point of view, you should be, sorry, familiar with data cleaning techniques and how each works. Um, you should not, you do not need to familiarize yourself with data cleaning key commands and code, because that we will definitely not be testing in your exam. We're going to move on to some data visualizations. I want to show you how this works in code. This is again something that is important from the perspective of your semester project. And इनका भी code नहीं test होता exam में. Essentially, we don't ask you to write code down for us. लेकिन you should be familiar with different types of visualizations. You're going to cover these in more depth in the upcoming lectures. You haven't done so yet. So you should be familiar with different types of visualizations, and as a data scientist, you should be able to tell what works best in what scenario. This has been tested in the past as well. So, data visualization is a graphical representation of information and data using different visual elements, like you have charts available, you have different kinds of maps and graphs available. It allows you to easily interpret and understand your complex data sets. It helps you highlight different patterns, trends, it helps you draw insights from your data. And this is how, as a data scientist, you are essentially telling a story as well. It helps you communicate your data findings clearly and efficiently, thus aiding in decision making and analysis. So, why is data visualization important? We're going to go over this quickly. You want to observe different correlations in certain relationships. You want to be able to observe trends over time. Sometimes आप दो variables के बीच में या तीन variables के बीच में relationship सिर्फ observe करना चाह रहे हैं. How one is changing as a result of the other changing or not. And then for a single variable, you could also want to understand कि उसकी क्या distribution है, for instance. You could also want to understand trends over time for different variables in your data set. Then you have frequency के कितनी unique values कितना frequently occur कर रही हैं. For instance, in my data set, I want to see कि एक gender कितना often occur करता है, which I could see in a bar graph. Then you could want to examine the market, identify opportunities, you would want to identify risk and reward. And with that, we're going to move on to some different types of basic charts. You have आप charts को classify कर सकते हैं into four broad categories. You have charts for comparison, where you could compare one or more data sets, or you could compare different items or show differences over time. Then you have charts that particularly are for relationships, where you want to identify relationships between different variables, where you want to identify connections. Then you have charts for composition, which are used to display parts of a whole and, for instance, change over time, like a bar graph or a pie chart. Then you have distributions, जहाँ पे maybe for a single variable you want to see how it is distributed. If like skew आपका किस तरह का है? Is it centrally distributed or is it skewed? Are there any outliers? If yes, are there a lot of outliers? What does the range for your data set looks like? इस example के अंदर you have, well, for instance, histograms or box plots. So anyway, these are some different kinds of charts. I want to show you how you will do this in code. We will not test this in code, like, and it should help you with your project. So this is the data set that we're looking at. I just showed you a while back as well. अभी ये economy of US का data set है. If I write df.info, so it tells me about the non-null values in every single column and the data type of that column. So this is what I have. जहाँ पे object है, वहाँ you have strings typically. Otherwise, you have floats and integers. This is what you will commonly see in your data sets. Anyway, मेरे पास हर जगह complete values हैं. I only have 48 entries in my data set. Inflation change के column में सिर्फ एक missing value है, जो हमने interestingly अभी last notebook में देखी थी. The very first value is missing. Let's begin with scatter plots. A scatter plot is a chart that uses dots to represent individual data points. They are often used to show the relationship between two variables. If you want to see the correlation between two variables, if you want to identify patterns or trends between, you can do this between multiple variables as well. And they are useful for identifying outliers or unusual data points. Data visualization के लिए you look at two more libraries in Python. You have matplotlib and you have seaborn. I will not introduce seaborn at all right now. I will show you matplotlib and seaborn in your upcoming tutorial, inshallah. For now, I will show you how you will do this in pandas essentially, क्योंकि pandas भी आपको allow करता है कि आप काफी type के visualizations बना सकते हैं. So you have a command, you call it on your data frame df.plot. You specify the x variable, you specify the y variable. ये आपके data set के अंदर से ही columns हैं. If I write df.columns, you will see कि ये वाले columns essentially available हैं. Year भी available है and GDP growth भी available है. And then you specify the kind of plot, and kind के अंदर मैंने scatter लिख दिया है. When I run this command, so it will make this plot for me. This is how it works. So when I ran this command, तो इसने मुझे exactly ये वाला plot बना के दिखा दिया. This is what I was looking for. Automatically it has labeled both of my axes as well. Then you have line plots available. Line chart is like a scatter plot, and then these points are connected with lines. Typically you use these जब आप correlation नहीं देख रहे, आप trend over time देख रहे हैं. For instance, the changes in revenue, changes in profits. You can plot multiple lines on a single chart as well to compare the trend between series. And you could compare between different subgroups. You could even compare between different variables in a single data set. We will look at that when we look at some more complex visualizations. But अभी हम देखते हैं कि how you can plot a simple line plot in pandas. So df.plot, you just need to specify the y column for a line plot, and then kind के अंदर I have written line. So this is what I've gotten. This is essentially what it has shown me. Over time, the trend for inflation is, well, for inflation, I can see what the trend looks like. Similarly, I can do it for between two different variables as well. Just say I've done year against GDP growth, I've done year and unemployment, and ये खुद ही आपको create करके दिखा देता है what is represented by that line. And then it has year over here and GDP growth and unemployment values on this axis. Moving forward, you have area plots. Area plots are a lot like line plots. All that happens is कि line plot के अंदर जो area है वो shade हो जाता है. So I write the exact same command, and then kind के अंदर I just specify area. And this is what it does for me essentially. Moving further, you have bar charts available, or another name that we use for them is bar graphs. Bar charts बनाने के लिए आपको value counts call करना पड़ता है. So let me show you how that works. You've covered this function in class as well. So df, suppose के I do this for the, what column was it again? हम columns को actually यहाँ पे display कर लेते हैं for our information. So once again, bf.columns, and yeah, so I will do it for inflation change essentially. This is what value counts gives me. इसका मतलब है कि ये तीन unique values exist करती हैं inflation change के column में. Decrease, increase, no change. ये null नहीं display करता, by the way. This just displays the unique non-null values. So 23 times decrease has occurred in this column, 21 times increase, and 3 times no change. इन वैल्यू काउंट्स के ऊपर मुझे कॉल करना पड़ता है ये वाला प्लॉटिंग ऑपरेशन. वैसे नहीं होता. सो इफ आई राइट वैल्यू काउंट्स के बाद डॉट प्लॉट kind equals, you'll see that there are multiple ways to do the exact same thing as well. Dot plot मैंने लिखा है, अब मुझे कोई variable x या y specify करने की जरूरत नहीं पड़ी, because I'm already calling it over here on inflation change के value counts. So when I run that, this is what it gives me. And this is exactly what I was looking for. Similarly, dot plot के बाद dot bar भी आप लिख सकते हैं. And that does the exact same thing for you as well. Similarly, df के बाद dot inflation change इस तरह specify करें तो भी your function will run perfectly fine. So multiple ways of doing the exact same thing. Moving further, you have histograms. Well, bar graphs you were using for your discrete variables. Histograms are more useful for continuous variables. They show you distributions of different variables. So bar graph में you have discrete data, histogram में you have continuous data. बार ग्राफ में फ्रीक्वेंसीज या नंबर ऑफ अकरेंसेस काउंट हो रही हैं. हिस्टोग्राम में यू ग्रुप वैल्यूज इनटू डिफरेंट बिन्स. व्हाट आर बिन्स? इट्स लाइक अगर मेरे डेटा की रेंज 0 से 100 तक है और मैं 10 बिन्स क्रिएट करूं, तो 0 से 10 तक फर्स्ट बिन होगी, 10 से 20 तक नेक्स्ट. एसेंशियली मेरा डेटा की जो रेंज है वो डिवाइडेड बाय 10 हो जाएगी. इफ द नंबर ऑफ बिन्स इज 12, then that's divided by 12. And this really affects what how the visualization will look. Like for instance, अगर मैं number of bins 2 रख दूं, तो वो मुझे 0 से 50 की रेंज में दिखाएगा कितनी वैल्यूज हैं, और 50 से 100 की रेंज में दिखाएगा कितनी वैल्यूज हैं, which is not probably not the level of granularity that I was looking for. So you can always play around with these and see how it affects your visualization, how well what works for you. The order of bars can be changed in a bar chart because it doesn't matter. Increase, decrease, no change वाली example में अगर order switched भी हो, so it doesn't really matter to me because, well, the categories are not in a certain order. My data is not ordinal, so it doesn't matter. However, in a histogram, आप एक order में चल रहे हैं. You have 10 to 20, then 20 to 30, then 30 to 40. So obviously you can't change the order of those bars. Otherwise, you will not be able to comment on the shape of your distribution or how your data is distributed. Just some differences. Again, हम columns देख लेते हैं. Unemployment के column के लिए हम histogram बनाएंगे because these are continuous numerical values. So I call it on the column, then I write dot plot kind equals histogram, and histogram के लिए you write hist. So this is what it did. इसने by default इतने bins बना लिए. Um, but you can specify the number of bins that you want as well, and then for each bin it gives you the frequency as well. So if I specify bins equals 10, तो वो 10 ही ग्रुप्स बनाएगा to group my data into, और वो 10 ग्रुप्स ऐसे बना रहा है कि मेरी रेंज को वो डिवाइडेड बाय 10 कर रहा है. You can plot the distribution of multiple variables on a single histogram as well. I will tell you what alpha means, but first let me show you how this works. This is the plot, and this is a wonderful plot because not only can I look at the distribution of inflation and unemployment, but I can also compare those two distributions. I can see how those two distributions vary, एक दूसरे से ये कितनी different हैं, एक single chart के, एक simple graph के, single graph के ऊपर. Now I will tell you, इसको call करने का तरीका तो बहुत simple है ना. All I did was कि I gave it a list of columns that I wanted to call it on. Then dot plot kind equals hist is the same as well. जो आपने alpha set किया है वो visibility के बारे में बताता है आपको. So यहाँ पे I can see the overlap, right? Alpha की value को अगर मैं 0.5 कर दूं, so let's see how that will affect my visualization. See, now these are lighter, which means कि जो overlapping regions हैं वो ज़्यादा clear हो गए हैं. अगर alpha की value को मैं 1.0 कर दूं तो overlap मुझे नहीं नज़र आएगा, which is obviously not ideal, I mean. And then you can pick a number in between that works for you. Alpha ranges from 0.0 to 1.0. अगर मैं इसको 0.0 set कर दूं तो मुझे सिर्फ overlapping regions नज़र आएंगे. Moving on towards pie charts, whatever you can make a bar graph for, you can also make a pie chart to represent that data. A pie chart helps you understand composition better than bar graphs do. Bar graphs में आपको पता चल जाता है कितनी unique values exist कर रही हैं, but in a pie chart you can tell proportions better than obviously you can tell in a bar graph. However, pie charts are not always preferred. इसकी हमारे पास we have a very good reason for this. If you have multiple categories जिनमें बहुत minimal difference है, जैसे for instance एक column के लिए I have 15 unique values. All right. It is a distribution. By the way, you can only make a pie chart for a distribution. Oh, I should correct myself over there actually. Extremely my bad. आप बार ग्राफ जिस डेटा के लिए बना सकते हैं आप हमेशा उसके लिए पाई चार्ट नहीं बना सकते. लेट मी गिव यू एन एग्जाम्पल एज वेल एक्चुअली. अगर मैंने एक सर्वे कंडक्ट किया फॉर इंस्टेंस जिसमें participants I asked my participants um, if they wear glasses and if they know how to drive. सो मैंने 3 ऑप्शंस दी उन्हें. और सपोज कि एक्चुअली मैंने उन्हें 4 ऑप्शंस दी जिनमें से उन्होंने सेलेक्ट करना था. द फर्स्ट ऑप्शन वाज आई डोंट नो हाउ टू ड्राइव एंड आई डोंट वेयर ग्लासेस. द सेकंड ऑप्शन इज आई नो हाउ टू ड्राइव. द थर्ड ऑप्शन इज आई वेयर ग्लासेस एंड द फोर्थ ऑप्शन इज बोथ. अब मैं इस डेटा को रिप्रेजेंट करने के लिए बार ग्राफ बना सकती हूँ. आई कैन मेक ए बार ग्राफ, आई कैन मेक अ काउंट प्लॉट, बट आई can't make a pie chart because it is inaccurate. This is not a distribution. Pie charts आप सिर्फ distributions के लिए बना सकते हैं. I have overlapping categories, which means कि ये जो distribution है, it will not sum up to 100%. So that's where a pie chart will not work. Similarly, pie charts are not preferred जहाँ पे बहुत ज़्यादा categories हों and close हो उनकी distribution. जैसे एक category 13% है and then the other is 13.5%. Pie chart में between the slices of pies, I will hardly be able to tell the difference between those two categories. So that's also where pie charts are essentially not preferred. Um, all right. It is still worth noting that pie charts are all right. We've already covered this actually. They do show you the relative sizes of different categories or components within a data set well though. So ये भी आप value counts के ऊपर call करते हैं. Dot plot kind equals pie. जिस तरह आपने kind equals bar specify किया था, and this is what it does for you. Then you have box plots. Box plots say you can understand the distribution of one particular variable. You can also make side by side box plots, and box plot के अलावा you have violin plots available as well. You're gonna cover them in class this week inshallah, so I will iterate in the upcoming tutorial then, the one after this. So a box plot is also called a box and whisker plot. You must have covered this before as well. You can use these to identify outliers. You can use these to understand the skew of distribution of your data, what the distribution looks like, if it's central or if it's right or left skewed. It helps you understand the spread of data and it helps you understand के if I haven't said already, outliers exist करते हैं या नहीं करते. To quickly iterate, this is how it works. These values are plotted minimum, the lower quartile, the median, the upper quartile, and then the maximum. So आपको clearly range भी नजर आ रही है data set की और interquartile range भी नजर आ रही है, where the IQR is the difference between Q3 and Q1 and the range is the difference between maximum and minimum. So I am calling it on a series df inflation because inflation is a continuous variable. Dot plot kind equals box and this is what it gives me. So ये जो bubbles हैं ये outliers को represent कर रहे हैं in my data set essentially. Then I can do something really cool as well. ये मेरे data frame के columns हैं. अगर मैं slice करूँ इन्हें और 5 onwards देखूँ तो 5 onwards मेरे ये columns हैं. अगर मैं इसको इस तरह कॉल करूं तो इन सब कॉलम्स में से ये खुद न्यूमेरिकल वाले पिक करेगा और उनके लिए साइड बाय साइड बॉक्स प्लॉट्स बना देगा. See, it automatically skipped inflation change because it's obviously not a numerical column. So this is what my data looks like now. Sorry, this is what my data looks like. Now the cool thing is not only can I look at the distribution of my individual variables such as GDP growth, inflation, and unemployment, but I can also understand how the spread of one compares to the spread of another. Lastly, you have color maps. Color maps are really यूजफुल विजुअलाइजेशंस क्योंकि आप दो नहीं तीन वेरिएबल्स को काफी इफेक्टिवली कंपेयर कर रहे हैं. So I am making a scatter plot. This is also how you can make a scatter plot. df dot plot dot scatter. You specify x and y just like before. कुछ मैंने इसमें additional entries डाली हैं. Before I tell you what each means, I will show you what a color map looks like. सो इन्फ्लेशन है, ईयर है, एंड जीडीपी ग्रोथ के लिए एक कलर बार है. Different color bars are available to you. I will show you more later as well when you cover this in class too. So ये आपके पास एक कलर बार अवेलेबल है. इसकी वैल्यूज की ये रेंज है आपके पास essentially. So now I know कि यहाँ पे मुझे जो बबल्स नजर आ रहे हैं, the more red the bubbles are, the higher the value of GDP growth was for that data point. The more blue that they are, the lower the value of GDP growth was for that particular data point. So what I'm doing is कि मैं तीन variables को इकट्ठे देख पा रही हूँ. This is what I'm specifying. X and Y axis के अलावा I specify कि color map के ऊपर represent कौन सा variable होगा, which is my GDP growth in this example. Then I specify the color map. I will not go into depth about these because you are still to cover different color maps. यहाँ पे मैंने cool worm set किया हुआ है. S equals size. Size just tells me about how big my bubbles are and how they are varying. So I have GDP growth, inflation and year. The cool thing about size is कि जब मैंने इसको unemployment पे set कर दिया तो मैंने एक fourth variable introduce कर दिया. अब मैं सिर्फ 3 नहीं 4 variables को compare कर रही हूँ. It can be a little daunting at first, but some bubbles are bigger than the others. The bigger the bubble is, the higher the unemployment was for that data point. So now I'm able to compare or look at the distribution for these four variables at once. अगर मैं इस size को खत्म कर दूं यहाँ से तो size uniform हो जाएगा, and now I'm just comparing three. So for the last part of your tutorial, I have added two versions to the same notebook given to you over here. इनमें से एक version के अंदर you have the same notebook that was covered in lecture number 5 for joins and merging. The version after this contains solutions to questions that are towards the end of the same given notebook. This I encourage you to attempt on your own later as well because this content is important from an exam point of view. I have two data frames over here. I have a customer's data frame in which you have four different customer entries and the attributes customer ID, name, and country. And then you have an orders data frame in which we again have three attributes order ID, customer ID, and the amount against the given order. You will observe that customer ID is common across both of these data frames, but quickly we're going to capture one important difference. You have four unique customer IDs in the customer data frame, ordered 1 till 4. In the orders data frame, customer number 2 is repeated twice, customer number 4 is missing, and customer number 5 does not exist in the customers data frame. All right, so let's move on and look at different kinds of joins, and we will perform these on our two data frames. For those of you who have already taken database systems, you will find this fairly similar to what you have already studied, just that now we're doing it in pandas. You have four different kinds of joins. An inner join is done in such a manner that, well, of course, you merge two data frames on a single or multiple common attributes. So when you perform an inner join, only those rows are selected across both data frames for which the given attribute has existing values in both data frames. So essentially, only common IDs are selected, or common values of whatever attribute it is that you're using are selected. When you perform a left outer join, so in that case आपके left वाले data frame में से attribute की सारी values select होती हैं, all the rows will be selected. But from your right data frame, of course, the remaining rows are not selected, and left में से attribute की जो values ऐसी हैं जिनके against values do not exist in your right data frame, so right data frame के बाकी सब columns में आपके पास null आ जाता है. And a right join pretty much works just the other way around. An outer join is like the union of left and right joins. But let's look at these through examples. So you have a pandas command pd.merge जिसमें you pass a data frame towards the left, then a data frame towards the right, then you select an attribute or a set of attributes जिनके ऊपर आपने merging operation करना है. So I'm doing this on customer ID because customer ID is common across both of my data frames essentially. And then you select the kind of merging operation or join that you want to do, in which case you can either write inner, left, right, or outer. So let's try running this command. I have 4 rows in my result and I have 3 unique customer IDs over here. 1, 2, and 3. And the reason that I only have 3 is because customers 1, 2, and 3 exist in both data frames. ये वो customers IDs हैं जिनके against you have rows in both of your data frames. So all of those rows are selected. The attribute that you are merging on the basis of is only repeated once, it's not repeated twice, and then all the other columns are selected across both data frames. So that is why our result looks like that. What if, although orders data frame के अंदर this was just called customer instead of customer IDs? So the question is, can I still merge on this attribute? And yes, you may still do that. Pandas allows you to do it. All you have to do is select left on, and similarly, we will select right on. So I know कि left के ऊपर my data frame is the customer data frame in which I have an attribute named customer ID. But in my orders data frame, I only have an attribute named customer. So this will essentially work exactly the same way. For now, we're gonna make our lives easier and just revert to what we were doing. Moving on, let's try a left outer join. The entire command is exactly the same except that now I have selected a left join as opposed to an inner join. And this is what the result contains. I have customer IDs 1, 2, 3, and 4. Customer ID 2K against, of course, I have 2 entries. So the thing is that customer ID 5 was not selected since I'm doing a left join, and customer ID 5 exists only in my right data frame, so it was overlooked. Customer ID 4 was selected since I am doing a left outer join and customers ka data frame is on my left right now. Although the thing is कि customer ID 4 के against I don't have an order ID and I don't have an amount. So what happened was कि उनकी जगह null values आ गई. These fields are missing in my data set now, in my merged data frame. So the question is, what do we expect when we do a right inner join, a right outer join then? In a right join, what will happen is the customer IDs 1, 2, 3, and 5 will be selected. 4 will be skipped since 4 doesn't exist in my orders data frame right now. And customer ID 5K against since I have no entries in the customer's data frame. So essentially, the customer name would be null and country would be null. But let's try to run this command. And essentially, it gives us exactly what we expected. Now, what exactly will happen when I do a full outer join? A full outer join will just return all the rows from both of my data frames. So essentially, it's like a union of a right outer join and a left outer join. It will just replace any missing values with NaN wherever I have them. So this is what I have. अब मेरे पास customer ID 4 की against भी entry है, in which case order key values are missing. And I have entries against customer ID 5, in which case the customer name and country, so basically customer data frame ke attributes are missing. On that note, moving on, you can also perform a join operation on multiple keys at once. Let me tell you how that works. So now I've updated my data frames essentially. Customers data frame ke andar I have the country, the customer name, and now I also have the city, which I did not have pehle. And then orders data frame ke andar also I have added city ka attribute, which wasn't already there. So now essentially I will try to merge on customer ID and city. So how does that work? अब मेरे keys के pairs बनेंगे. So I have 1 comma New York, I have 2 comma Toronto, I have 3 comma LA, and then I have 4 comma Vancouver. Essentially orders data frame के अंदर भी I have 1 comma New York, so ये वाली row actually merge हो जाएगी first वाली. And then I have 2 comma Toronto, 2 comma California. 2 comma California should technically be skipped when I do an inner join, because 2 comma California does not exist in my customers data frame. Similarly, I have 3 comma LA, which does exist in my customers data frame, and then I have 5 comma Chicago, which is missing from my customers data frame. I would like you to pause over here and think about what the result of each join should look like. But I am going to continue. So essentially, the command is still exactly the same, but on ke andar, I have actually passed a list of attributes on which I want to perform a merge operation. So this is what my result looks like. Essentially, now I have only three common rows in between them: 1 comma New York, 2 comma Toronto, and 3 comma LA. उसके अलावा मेरी rows match नहीं करती, so I have skipped all the other rows. You can experiment with this, try a left join, in which case this row will also be included, 4 comma Vancouver, but uske against order ID and amount would be null as expected. And I could try a right join as well, in which case 2 comma California and 5 comma Chicago are going to be there, but unke against customer name and country would be null. Essentially exactly as expected. All right, moving on to one last kind of join, which well, to be honest, you will not find much use for this very often. A cross join is just a simple Cartesian product of two data frames. So ये सारी rows के सारे combinations बना देता है. In this case, if I have 4 rows in my customers data frame and 5 rows in my orders data frame, so 4 multiplied by 5 equals 20. I will have 20 combinations. So for instance, if it picks this row, so इस row के साथ ये turn by turn in 5 की 5 को merge करेगा. So I will have 20 rows in my resultant data frame. And how may you just specify cross? You don't have to specify on, because you're not performing the join on any particular key. You're just combining the rows together. You're making as many combinations as you can. So you can see कि ये start 0 पे करता है and end 19 पे करता है. I have 20 rows over here. You will also notice that since customer ID is common between the given two data frames, so उसने एक के आगे automatically underscore x लगा दिया and दूसरे के आगे automatically underscore y. By default, this is just how Pandas behaves whenever you have common attribute names across different data frames that you're merging on. Um, Lastly, you can also perform a join operation on an index. So I will show you that we are still working with these exact two data frames. And now what I'm doing is that I am setting the index to customer ID. Like we have seen, this is very much possible. So इसको हम ऊपर ही set कर देते हैं. And then let's see how our display changes. So essentially अब आपके पास customer ID चला गया है यहाँ पे. By the way, wherever it was non-unique, ये उसको I think उसने replace कर दिया. My bad. Let me just quickly try and run this again. Yeah, there we go. So we're gonna perform a join on the index. And like you can see, I have attempted to perform an inner join. What has changed over here is that I'm still using my pd.merge command. I'm still giving it a left data frame and a right data frame, and I'm still specifying the kind of join that I want to do. But now I select the left index as true and the right index as true, which essentially means कि index के अंदर जो common values हैं ये सिर्फ उनके ऊपर merging करता है. And then you can just as well try and run this for a left join or a right join as well. We're going to, oh, you can also do it for a complete outer join. We're going to move on towards a challenge which we will attempt right now. And then there's one challenge that I will leave up to you guys, but essentially I will add the solution to LMS so you can check it out though. I have two tables over here. I'd rather just show you the two tables that I have over here. So आपके पास एक employees data frame है and then you have a unique employees data frame. Employees data frame के अंदर you have an ID against a name. Employee unique data frame में you have an ID against a unique ID. So essentially it means कि ID repeat हो सकती है multiple times. But आपके पास हर ID के against एक unique कोई employee की mapping given है. Oh, essentially, even ID is not repeated in your simple employees data frame. Anyway, when we do a merging operation, we can do it on ID and we can try and extract the unique employee IDs against the names of your given employees. And that's exactly what you need to do. Perform the correct join to get all employees and their unique IDs. So essentially, this is what we need to highlight. All employees need to be selected, which tells us कि employees data frame में से हमने सब कुछ select करना है. So you can pause over here and think about the kind of join that should work well in this scenario. You will be using a left outer join given that the employee's data frame is towards your left. This will ensure कि ये सारी rows included हैं. जिस row के against entry नहीं exist करती in the employee unique data frame, उसके against the unique ID will be null. So let's actually quickly write this code down over here. Let's call it our data frame, or rather, let's call it our merged data frame is equal to pd.merge You add a data frame to your left and you add a data frame to your right. I will merge on ID, and the kind of operation that I want to do is a left outer join. Uske liye you just have to specify left. So essentially, this was exactly the result that I expected. Employee ID 3K against I had no entry in my employee unique data frame, which is why the unique ID against this is null. It is missing. Next, you are required to replace the null values in the unique ID column with well null. So I will pause over here. I would recommend you guys to pause over here and think of how you will solve this because we have covered this in data cleaning. I am going to add a simple solution over here. So I have my merged data frame. Merged data frame ke under my column is called unique ID. So I think I can do this using a simple lambda function with dot apply. So lambda value and you are supposed to return null if the value is null. So null if, so iske liye you have a command pd.isNA which we've covered in, well, I think we've covered previously within this tutorial. So pd.isNA and then I will pass my value. Else I will just return my value exactly the way that it is. Let's see if this works. Perfect. So this is essentially what we were looking for. आप इसके लिए separately भी function define कर सकते हैं. Clean merged IDs, suppose that's what I call it. And इसको एक certain value pass होगी. Let's call it X, let's call it val, we don't care. If pd.isNA X is equal to true, so you will return null, else return X. And then I can just replace my lambda operation with exactly this, and that should work the same way. Alright, now you have to select only the ID and unique ID columns. So ये तो essentially बहुत ही simple task है. I will just pass a list of all the columns that I want to select. Oh, this is merged df. And this is exactly what I was looking for. So this is what your result should have looked like. There is a challenge for you at the end of this notebook, and I will leave this for you to try out on your own, but I will definitely have the solution updated on LMS. All right, that's going to be all.